Alright, so we did 5, 6, and 8. Let's start with 5. F of x equals negative 2x squared plus 4x. Okay, we talked about how the very first thing that we do is we find the vertex. So to find the vertex, we're going to use our formula x equals negative b over 2a. It's on your worksheet. So then we plug into this. So x equals negative parentheses 4 over 2 times negative 2. Then we simplify. So negative 4 divided by negative 4 is 1. So we see that our x value is 1. Now we're going to find the y value. To find your y value, you take your x value and you plug it back into the function. So f of 1 equals negative 2 times 1 squared plus 4 times 1. Now we can simplify this expression. Remember, please excuse my dear Aunt Sally. So parentheses and exponents. 1 squared is 1 times negative 2 is negative 2 plus 4 is 2. So that comes out to be 2. So your y value is 2. So once we have our vertex, then we can go about doing our graph. And again, the parts that really matter are the points. It all matters, but the points are what are going to get you the grade. Drawing the curve is just a sketch. So our first point is 1, 2. So we're going to go to the right 1 and up 2 and put a point. Now, once you have your vertex on the graph, it is a very good idea to go ahead and draw your axis of symmetry down through that vertex. And the reason we do that is so that we don't accidentally put the axis of symmetry through the wrong point. It goes through your vertex. Now once we have this, now we can go to our second point, which is almost always our y-intercept if we're in standard form, which we are here. So what is the y-intercept in this problem? 0. So I didn't write the 0, but it's really 0. So plus 0. So that is here at the origin. And the last step is to reflect your y-intercept across the axis of symmetry. So if it's 1 unit to the left, the third point is going to be 1 unit to the right. Alright, so once I have my 3 points, now I draw my curve. And understand, the curve is not a V shape, it is a U shape. So we're going to curve it like a U. Now again, it doesn't have to be perfect, but it needs to be U-shaped rather than V-shaped if at all possible. Okay, any questions about number 5? Now, keep in mind, you're going to be responsible for this stuff. I'm planning on having a little mini quiz over graphing from standard form tomorrow at the beginning of class. Alright? So, very important. I'm talking about one problem. That's going to be a quiz. Alright? So, you're going to be responsible for this. Alright, let's look at number 6. Alright, number 6. F of x equals 2x squared plus 4x plus 1. Alright, so today we're going to be talking about graphing from vertex form. We've already talked about graphing from standard form. So let's take a look. Alright, graphing quadratic functions in vertex form. Okay, so graphing quadratic functions in vertex form follows the formula f of x equals a times x minus h, in parentheses, squared, plus k. Now these variables all have important meaning. From this form, h and k are our vertex. H is the x value of the vertex, and k is the y value of the vertex. And you may say, well, why don't you use x and y? Well, we don't use x and y because we're using x and y other places. See, here's x. Here's y. F of x is our y value. So we can't use x and y to represent the values of the vertex. But when it comes to plotting these graphs, these coordinates on the coordinate plane, the k is representing your y and the h is representing your x when you graph that point. Alright, so let's take a look at some examples of where we're going to find the vertex. So example 1. F of x equals 3 times x minus 4 squared plus 2 is our first quadratic equation, quadratic function rather, that's in vertex form. Alright, so let's take a look. The vertex, like we said, is going to be the h value of the vertex is the opposite of what's inside parentheses. So we've got a negative 4 in here, right? And so the opposite of negative 4 is positive 4. So the x value of the vertex, which is really h, is 4, whereas the k value, which represents our y value of the vertex, is 2. So 4, 2. Now, if you notice, this is a whole lot easier than finding the vertex in standard form. It's automatic. It's instant. There's no work required to find the vertex when you're in vertex form. Let's look at the second example. So, f of x equals 1/2 times x plus 2 squared minus 5. So here we have another one that's in vertex form. So, without saying it out loud, say it to yourself. Don't say it. I'm going to call on everybody to say it in just a second. So, what is the vertex? Correct. -2, -5. This value that is out front is your A value, and that A value is the same kind of A value that we had when it came to standard form. Same deal with standard form. If this A value is negative, guess what this graph's going to do? It's going to go down. If the A value is positive, it's going to go up. So in these two cases, the A values are positive. Therefore, it's going to face up. So here's a third example. F of x equals -1/3 times x plus 5 squared minus 3. So you can see that the vertex is going to be -5 because that's the opposite of what's in parentheses. -5, comma, -3. Now, since we have an A value that's negative, what is this graph going to do?
Go down.
Yep. This graph will face down because our A value is negative. Okay, so here's our first example where we're actually graphing from vertex form. And so we have f of x equals -3 times x minus 2 squared minus 4. So the first point is always determined by the function itself, and that is the vertex is the opposite of what's inside parentheses, so that's the opposite of -2, which is 2, comma, what's outside the parentheses to the right, and that's our k value. So we've got 2 comma negative 4 for our vertex. Now, the second point is determined by looking at the a value. Our a value is negative 3. So use the a value as if it were the slope to get the second point. So I've graphed my vertex, 2, negative 4. So to the right 2, down 4. Remember, always put your axis of symmetry through your vertex first. Now I graph my second point using the a value as if it were the slope. So negative 3 over 1. So that's down 3 to the right 1, correct? So from my vertex, I'm going to go down 3, 1, 2, 3, to the right 1 to get my second point. And then my third point is the same as with standard form. That is, just reflect across the axis of symmetry. So, since my second point was 1 unit to the right of the axis, my third point needs to be 1 unit to the left of the axis. Make sure you're careful when you're doing this, that you don't go too many points over, too many units over. Okay, so there's your example. Exactly, so we can work backwards to write the function from the graph. Now you have to be careful with this. It won't always work out, perfectly, or it won't always work out easily by going backwards, but in this case it does. So we know our vertex is 1, 4. Alright, we know that our a value is negative 1, 4 because how is it graphed? Down 1 to the right 4, and we have a point. Alright? Now, I guess technically you could say down 1 to the left 4 too, but that wouldn't work out as, that wouldn't be right because we want our a value to be negative because it's facing down. So how would it be written, Jamal?
Negative 1, 4. It's minus 1. Plus 4.
Squared.
Squared plus 4.
That's it. And don't forget your f of x. That's it. Very good. So we can go backwards and forwards from these graphs. Now I'm not going to spend as much time, we're not going to spend as much time going backwards. When I give you a graph writing the function, it's going to be a small part of what we do. The main thing that I want you to be able to do is be able to look at the function and do the graph. But if you can go backwards and forwards, that tells me that you truly understand it to its fullest. All right.